Okay, welcome to the second part of section 2.6 on rational functions. So these are some harder examples now. I don't know if you can see what's different about this first one, but it's that the power of the numerator is bigger than the power of the denominator. So this is actually not going to have a horizontal asymptote, but instead it's going to have an oblique asymptote. So let's do the first part. It's still going to be y is equal to. Really a little bit faster. So x-intercept something comma 0, y-intercept 0 comma something, vertical asymptote x is equal to, domain x is not equal to. We find the x-intercept by letting y be equal to 0, which is actually just letting the numerator equal to 0. I see an x squared, so I factor. And my two answers are 0 and 1. So this has two x-intercepts. I find the y-intercept by letting x be equal to 0. And that gives me 0 over 1, which is 0. I find the vertical asymptote by letting the denominator be equal to 0. I love these. They have a nice pattern to them. Which means that's the one number that x can't be. And now the oblique. So the way you find an oblique asymptote is by doing long division, which we learned earlier in this chapter. Now you get to practice it. X plus 1 being divided into x squared minus x plus 0. Make sure you have every part accounted for. So when I do this, I get x times x plus 1 is x squared plus x. Don't forget to change the color and subtract. That gives me negative 2x plus 0, which means I need a negative 2 up there. Multiply. Negative 2x minus 2. I change the color to subtract. And I get 2. So my remainder, I refuse to write the big R. Remainder is 2 over x plus 1. Could you have done this using synthetic? Absolutely. You can't always use synthetic. Remember, the rules for synthetic is only if you have a linear, specifically just x plus or minus a number. So if you'd use synthetic, you'd have to remember to put a negative 1 in the box. And you'd still have to remember this 0 here. That would give you add, multiply, add, multiply. That would be your remainder. And this would become x minus 2, which is what we got. So whichever way makes the most sense to you. The important part is this is what goes here. This is what goes here. The remainder will matter next year in calculus. I'll teach you what significance that has. But right now, it is literally the oblique asymptote is just this. And I can explain why, but first let's just concentrate on getting the oblique asymptote. So I graph that line. I start at negative 2. It has a slope of 1. And I'm going to go back and actually draw the line. So our graph is going to follow this line. And I have a vertical asymptote at negative 1. And I have some points to plot. I know there's an x-intercept at 0 and at 1. All right, that's enough for me to draw that branch. When you know a couple points and an asymptote, you can follow the asymptote and go through the points that you know. Do you have a suspicion where the other one is? I think it's going to be down there, but we're going to make a little table. Make sure you pick a number past the negative 1. So negative 2 will work because you need it to land in here or in here. So you have to pick something before negative 2. Negative 2 squared is 4 minus a minus 2 over negative 2 plus 1 is 6 over negative 1, negative 6. Negative 2, negative 6. And that's enough for me to plot it. It's very tempting to make this point the maximum. Try not to do that because you actually don't know that it's the maximum. So a lot of kids just touch it. But you don't actually know that that's the maximum point right there. So I try and go a little bit above it and then come down on it to make sure I don't make that assumption. That's how you do an oblique one. So it wasn't so bad, right? Just you have to do a little work to get that asymptote. Let's do another oblique one. If you want to try this one on your own, you can. But of course, I'll do it with you. So X-intercept, something comma 0. Y-intercept, 0 comma something. Vertical asymptote will be x is equal to a number. Horizontal, or in this case, oblique, is going to be y is equal to something, but this part doesn't change. And the domain is what x can't be. So the x-intercept is letting y be equal to 0. Only the numerator matters because I can clear the fraction. I see an x squared. What do? I factor. And I find out that there are two x-intercepts, 2 and -1. So 2, 0 and -1, 0. To find the y-intercept, I'm going to let the x be 0. So 0 squared minus 0 minus 2 over 0 minus 1 is -2 over -1, which is 2. So I already know a lot. I know 0, 2, I know 2, 0, I know -1, 0. Vertical asymptote is found by letting the denominator be equal to 0. Now I know an asymptote is at 1. And I also know that x is not equal to 1 at any point on this graph. And here we go. The oblique asymptote. How do I know that it's going to be oblique? Because the power of the numerator is higher than the power of the denominator. You're welcome to use synthetic if you can remember that it's going to be a positive 1. And then we have 1, -1, -2. So add, multiply, add, multiply, add. This is my remainder. This is my function. Y is equal to x plus 0. So y is equal to x. I don't really need to write plus 0. So what does that look like? It just starts at 0, 0, and it has a slope of 1. I'm terrible at drawing lines, so I always have to draw the points first. Maybe you're better at it than me. And this is one of my favorite graphs because though I did a little bit of work to get that oblique asymptote, now I have enough points already filled in that I can actually make the graph right now. It's going to follow the asymptote, go through those points, and then follow the asymptote. Follow the asymptote, go through the point, and follow the asymptote. I did not have to make an XY table. As long as you have at least one point in each branch, that's good enough. All right, you guys are doing great. Honors, I realize you're doing both of these videos in one day. Thanks for hanging in there. Okay, so this is a sad problem for me because normally people do this one wrong in class, and then I walk over to their group and I'm like, I know what you did wrong. You forgot to do step 1, but I can't really just sit here and wait for you to do it wrong. So I'm just going to show you that the main thing that people do is they forget to do step 1 because, like I said, it doesn't happen very often, but you should always try to simplify. So when you do that, you get x minus 3 times x plus 2, and this cancels. This is literally the identical function to this one. Just like 5 over 10 is 5 times 1 over 5 times 2, you cancel that. 5/10 is literally the identical number to 1/2. Well, this big complicated function which we don't want to graph, is actually just this function, which will be really easy to graph. I'm going to make my little table here. Literally, I just write that every time. And now I can use this nice reduced one to find my answers. So there's an x-intercept whenever y is equal to 0. So 0 is equal to x minus 1 over x minus 3. I'm losing the pen again. X minus 3. So I clear the fraction. And what's the only part that matters? The numerator. So x is equal to 1. That's my x-intercept. Y-intercept is when x is equal to 0. And again, you don't even have to show this work. If x is 0, you put a 0 in there and a 0 in there, you're going to get 1/3. We show work to get partial credit for careless mistakes. Vertical asymptote, let the denominator be equal to 0. So x minus 3 is equal to 0. X is equal to 3. So what's the one number that x can't be? X can't be 3. My horizontal asymptote, the powers are the same, and the number in front of them is both 1. So 1 divided by 1 is 1. Okay? I'm just going to erase those. We don't really want them there. So let's see if we know enough to graph it. Let's make my asymptotes first. There is an asymptote at y is equal to 1. There is an asymptote at 3. Asymptotes are great. They mean that you have to plot less points. I have a point at 1, 0, and at 0, 1/3. Both on the same branch. So it didn't help me as much as I wanted it to. But I still only have to find 1 point on the other branch. To get a point on the other branch, you're going to have to pick a number bigger than 3 because you want to be over here in this area. So I just picked 4. I'm not that clever. 4 minus 1 over 4 minus 3 is 3 over 1, which is 3. So at 4, it's 1, 2, 3. And now I can plot that whole branch. There you go. With just one single point, I can make the whole branch. All right, opportunity for extra credit for CP and for honors. Sorry, this is not extra credit. You will actually lose points if you forget this. So this graph has a hole in it. And if you take calculus next year, even if you're in CP, you will need to understand this concept of a hole. If you typed the original function into your graphing calculator, there are actually 2 numbers it would not plot. What are they? X is not equal to 3, and X is not equal to -2. Because when your calculator does it, it doesn't do asymptotes and x-intercepts and y-intercepts. It literally just plugs in. It's a computer program. It's plugging in all these values. It's making them all and then making it into a graph. So when it gets to -2, because it's trying to plug -2 into here, it gets a 0 in the denominator and it doesn't plot it. There's no intercept, there's no asymptote there, but it still can't be a point on this original graph. So if this is what you typed into your graphing calculator, it would not plot anything at 2. It would -2. It would literally skip right over it. So right here, as funny as it is, the graph continues, and then there's a hole right there. You don't have to know the y value. You can literally just erase it right there and then fill it in as, nice big hole there. So at -2, wherever your graph is, there's actually a hole. So CP, if you remember to make this hole on your graph, when you see one of these on your test, yes, one of these will be on your test, then you'll get extra credit for it. Honors, if you forget the hole, you'll lose a point. You must know where that hole is. And we'll learn more about what that hole means when we get to calculus. Everything's gonna be great next year, calculus. Okay. Oh, good. Not an oblique, so there's no long division. So it's just a review problem. It's just more practice. I do think I'm just going to check to see how this simplifies. I feel like just looking at it at a glance, since this is a 9 and that's an 8, I don't feel like the factorings will cancel, but I like to check. So minus 4 and plus 2, yeah, nothing cancels. But factoring was still good. It still helps me find the x-intercepts, because the x-intercepts happen when y is equal to 0, which means the numerator is equal to 0. So now I can see that 4 would create a 0 and negative 2 would create a 0. So it was still helpful to have it all factored. The y-intercept is not better in factored form. It's much easier to plug the y-intercept into the original. 0, 0, negative 8 over 0, negative 9 gives me 8/9. But the factoring is helpful for the vertical asymptotes, because you were going to take that denominator and set it equal to 0. You were going to factor. But now I can see that it's x is equal to 3 and x is equal to negative 3. Those are the two, not actually in that order. If I don't want you to be confused, the x plus 3 creates a negative 3 and the x minus 3 creates a positive 3. The horizontal asymptote, because the powers are the same, it's 1 over 1. Y is equal to 1. And the domain is what the x can't be. And you can write it as plus or minus 3. So let's draw these asymptotes. Y is equal to 1. X is equal to 3. X is equal to negative 3. And I know quite a few points. Hopefully they're not all on the same branch. Let's see. 4, 0. Nice. Now I got a branch. Now I got something over there, right? So that one point gave me this entire branch. I know negative 2, 0. All right. I can't draw the whole branch. Don't know yet if it goes up or if it, like it might do this, or it might do this, right? So you're not sure yet. That's not enough to tell. And we know 0, 8/9. Still not really enough to tell. Still could come right back down. Okay. Except that if it were to go down, I can tell you right now that the graph is never going to do this. One of them is going to be going up. So since this started to go up, I don't think it's going to come back down because this one's on the bottom. So I feel pretty confident. Oops, I kind of missed that. I feel pretty confident that the graph goes like this. How could you check that? Well, you could make a table and plot 2, and 2 should be up there somewhere. So you have to ask yourself which is easier, to plug 2 into the factored form or to plug 2 into the original. So in the original, it would be 4 minus 8 over 4 minus 9. These cancel, so negative 8 over negative 5, which is 1 3/5. So at 2, it's 1 3/5, so it wasn't even as high as I drew it. But it told me enough that it was definitely going up. Okay, 1 3/5. Now I still need something over for this branch. None of my points gave me this branch. So I'm going to use negative 4. And just to show you, if you choose to do it in the factored one, negative 4 minus 4 is negative 8. Negative 4 plus 2 is negative 2. Negative 4 plus 3 is negative 1. And negative 4 minus 3 is negative 7. So 16 over 7, which is 2 2/7. It doesn't matter to me whether you plug it into the unfactored one or the factored one. So I did one of both ways to show you. Okay, so negative 4 and 2 2/7. Is that where you expected it? I hope so. I expected it up there because it has like a nice symmetric look about it. Last one, you did it. This one is a little bit different. But we're going to start the same way. Something comma 0, 0 comma something. X is equal to, Y is equal to, X is not equal to. Just start with that. Okay. So an X-intercept is always found by letting the Y be equal to 0. But when you clear this fraction, this side still becomes 0, and this side is -1, and that's not true. So there is no X-intercept. The Y-intercept is found by letting the X be 0. -1 over 0 minus 2 is -2 squared, so -1 over 4. So I'm going to plot that, 0, -1/4. The vertical asymptote is setting the denominator equal to 0. So square root both sides, and you get x minus 2 is equal to 0. So x is equal to 2. So there's going to be a vertical asymptote at x is equal to 2. Horizontal asymptote. So the degree of the numerator is actually x to the 0. So it's definitely less than x squared, even though it's on the outside of the parentheses. If you multiplied it out, you'd have an x squared. So it's going to be y is equal to 0. And remember, the vertical asymptote and the domain always go together. So if there's a vertical asymptote at 2, then x can't be 2. This graph is never, it would not work ever to plug in a 2. That's what that means. So I only know that one point. Oh, I didn't graph my horizontal asymptote. Asymptotes are great. They really help you make a graph with just one point. So I just have one point, and yet I can graph this entire branch based on that one point in the asymptotes. So we just need one point over there, right? Let's make a table. And I'm going to pick 3. That puts me on that side of it, which is going to be -1 over 3 minus 2 squared, which is -1 over 1 squared, which is -1. 1, 2, 3, -1. Okay. So the reason that this graph is on here is because I don't want you to think that they're always 100% of the time going to be in opposite quadrants. This graph does go like this. It's unusual, but it does occasionally happen. And the reason that it happened is because of that square, because x minus 2 squared is kind of like the bounce does something unusual to it. Every single x coordinate that's after the 2 is going to be the same as before the 2 because the number is going to get squared. So if you were lazy and you were like, oh, I see this point, I'm not actually going to make a table, I'm just going to throw the other one over there, you would have gotten this one wrong. So you do have to always find one point. And of course, you either question yourself and say, oh, I must have done it wrong, or you say, is there something unusual about this? And there is, and that is that it's x minus 2 the quantity squared, which was the first time we saw that. So honors, you have some practice to do on these. But CP, yours is broken up into 2 days. So since you've just watched this video, you're now able to do this day 2 homework. All right, you guys, you're doing a great job. Have a great day.